This is day 2 on simplifying rational expressions. And so let's take a look at our first problem. And so whenever we look at one of either the top or bottom of the fraction, you see that the leading term is the constant, and then the x term is negative. You're going to want to not only pull out a 3 in this case, but also pull out a negative, because then that way the x term will become positive, and you'll see the canceling that ends up happening here. So again, when you see this as a negative, make sure that you take out a negative. So it's always when the leading term is the constant and the next term is a x term and it's negative, not only take out the number that's in common, but take out a negative as well. So negative 3 is what we have on top, and we factor. Now I'm going to put the x term first. It's positive x now, and a negative 1, minus 1, because 3 over negative 3 makes negative 1. Take out the common factor here. It'll make the factoring a lot easier, and you'll see more stuff that can cancel. So when we do that, I've got x squared, a plus 6x, and a minus 7. And so when I go ahead and do some reducing, I can go ahead and cancel out these 3's right now. So those will be gone. So let's go ahead and factor this a little further. And so I've now got this negative sign still, and the x minus 1 down below. It's a trinomial, so it's going to factor as two binomials if it factors at all. An x plus 7 and an x minus 1 is the way it ends up factoring, to subtract to make that positive 6. So we do end up canceling out the x minus 1s, so we still have that negative sign. So think of it as like negative 1 over x plus 7, and that would be our answer. So we'll get another chance to practice one of those in today's lesson. Let's take a look at this next one, though. We've got a trinomial, no common factors, so we'll go ahead and factor it. And numbers that multiply to make 36, but add to make 12 would be 6 and 6. And then down below, I see a common factor. I see 12 can be divided by each of those. So put the 12 on the outside, do the division, see what's left over. We've got it 12 times x plus 6. So we can now cancel out just one of those x plus 6's. There's only one that cancels out on the top and the bottom, leaving us just with this x plus 6 on top. And down below we get a 12. That's as far as we can take the problem. Well, the next one looks small compared to the other ones. Well, just one common factor. I see that a goes into each of these terms. Now when you pull out an a on the bottom, so I still have that a on top, when I pull out the a over a makes 1. And 2a over a makes 2. So we can cancel out these a's. Now, when you cancel out those a's, there's still a number left on top, and on the bottom too. A over a just makes 1. So we have 1 over 1 times 3 when we add those numbers. So 1/3. That's my answer. Well, looking at this one here, I see it's a trinomial, no common factors. So I'm going to go ahead and try factoring as 6w and w. And actually, I might end up changing that. Let's go ahead and erase that. I'm going to end up starting with the 7 first. 7 times 1. I know those numbers multiply to make 7. Now, let's go back and think about this. I need to subtract to make 11. So I don't want to make it too big. I'm going to put a 2w here and a 3w here. See, this will make a 7 times by 2 makes 14, and this makes 3. And yes, those will subtract to make 11. So to make it a positive, I want 14 to be positive, and the negative sign right there. Okay, so I've got the factored form. Let's rewrite that. So I've got the 2w minus 1, got the 3w plus 7. So over here I see a common factor of 3. Let's go ahead and divide by that 3. So we'll put that 3 on the outside. And when I do that division, I'm left with the 2w minus 1. And I do get some canceling that occurs here. The 2w minus 1's are the same on top and bottom. So we're left with that 3w plus 7 all over 3. That's as far as we can take the problem. Well, up on top of the fraction, we see it's a quantity being squared. It's already factored. So again, what that means is it's just x plus 1 and another x plus 1. So down below, we just need to factor that. So it's an x squared plus 2x plus 1. Well, for it to factor, it's going to be two binomials. 1 and 1, the only numbers that make 1 are 1 and 1. They have to be both plus signs to multiply to make a positive and add to make a positive 2, which is what we get. Now, here, everything cancels. So the x plus 1's and these x plus 1's are canceling. But remember, just like over here, The a's canceled out. We are left with 1 over 1, and that's what we have here, 1 over 1, which is just 1. Over here, again, this is just like the first problem, going back to it. Now, notice that your constant's positive, but your x term, in this case x squared, is negative. So you can't take out a common factor except for -1. It'll make the factoring easier, plus you'll see the canceling that occurs. So let's rewrite it. X squared minus 25. So the sign switched when I pulled out that negative. And down below, we'll go ahead and factor this. Factors to an x minus 5 and an x plus 2. Numbers that multiply to make -5, but add to make, or multiply to make -10 or -5 and 2. But those do subtract to make -3. Now up top, we've got a difference of squares. So let's go ahead and factor that. X minus 5 and another x plus 5. And then down below, we've got an x minus 5 and we've got an x plus 2. And then from there, we can go ahead and do some reducing. So the x minus 5s, they cancel out. So what's left over? We've got a -1 times by x plus 5. And then down below, we've got an x plus 2. And so that's our answer. Now, you could end up seeing the answer with this distributed, and you've got the sign switched in, -x minus 5 all over x plus 2. Either way would be fine. I prefer to keep it just in that factored form. So those are problems similar to tonight's homework. Good luck.